Okay, so this is a problem about pulling a mass that's suspended on a rope over to the side. So we do the same thing we do with all these kinds of problems. We choose an object and we draw the free body diagram. So here's the object, and the forces are two ropes. There's the force of tension due to rope 1, and there's the force of tension due to rope 2, and gravity, m times g, the force of gravity. And we might want to choose axes that look sort of regular, I guess. X is horizontal, y is vertical, increasing up and to the right. So that means that we have to take this force of tension due to the angled rope, and we have to separate it into x and y components. We were told that the rope has some angle theta with respect to the vertical, also this angle, theta. And so the sum of the forces in the x direction and the sum of the forces in the y direction. X direction is going to have, let's see, x direction is going to have the sorry, my computer just burped there for a second. So in the x direction, we're going to have the force of tension number 2, and in the negative x direction, we're going to have the force of tension 1 times, well, sine or cosine, it's sine because it's the side opposite the angle. And that is going to be mass times acceleration in the x direction. In the y direction, we're going to have the force of tension from rope 1 cosine theta in the positive y direction and minus mg in the negative y direction. And this is ma times y. And we know that because it's suspended, because this is a statics problem, both of these forces are 0. So we don't know the force in rope 1, and we weren't asked for it. We were asked for the force in rope 2. So what we'll do is we'll take the first, let's take the second one actually, and solve this equation for the force of tension in rope 1. This is mg divided by cosine theta by adding mg to both sides and dividing by cosine theta. Then I'll plug that back in to the first equation, and I get that the force of tension 2 mg over cosine theta times sine theta. So wherever I saw ft1, I just plugged in what I had solved for previously, and that also equals 0. So I was asked for the force of tension in rope 2, and that's mg sine theta over cosine theta, also known as mg tan theta. And that's the answer. But notice that we didn't have to use that set of axes. We can redraw the free body diagram. So here's the free body diagram, the force T2 and the force T1 and mg. We could have just as easily chosen axes that look like this instead. So we can have x and y. So that means that we have to separate these into components. Now F2 is all in the y direction, but it's the F1 and the force due to gravity that have to be separated into components parallel to the x and y axes. So this angle here is theta. How do I know that? Because we were told this angle is theta, which means this angle has to be theta. So now, in fact, I don't even need the forces in the y direction. All I need is the forces in the x direction. And in the x direction, I have ft1. Now I want cosine theta minus mg sine theta, and that's ma in the x direction, which is 0. And so I get that ft1 is mg sine theta all over cosine theta, or mg tan theta. So I get the same thing, which makes me feel good about how I'm solving this, because the choice of axes doesn't matter. The answer is the same. Okay, that's my solution.